Until we have questions, I have one for you, Megan. Just, do you have any idea when this 2 meter per pixel mosaic of the South Pole area will become available on the PDS, and if it will?
At least a version of it will. We haven't really decided what we're gonna do with that particular mosaic, whether we just want to get it out there in some version or whether we want to try and make those subsolar longitude mosaics to kind of go with it. That's like something I'm going to deal with kind of right when I get back, but probably in a few months, by the end of the year, for sure, we'll have a solution to that problem. Yeah, that's a great question.
Yeah, and thank you for the hard work with the mosaics. That's awesome. Yes, question online for Sasha. Can we display it? So the question is, do you know the main composition major element of the pyroclastic deposits?
Yeah, at the moment we are just analyzing the composition of the pyroclastic deposits. That is part of my PhD study to look out what the major components of these pyroclastics are. So at the moment, I cannot give a proper answer what are the major elements for that.
Another question to Sasha, Igor Drozdowski, EAC. For the mission concept that you presented, what evaluated your sample size? What would you consider as a good sample you would like to collect during this mission?
Yeah, as a good sample, I would consider that we know the source from where the sample is coming from, and good sample would be for me from a fresh crater that we get updates into the lower part of the lunar chronology function. So the only thing that we have at the moment for this part is Copernicus crater, and it would be nice to have some updates there to get a more accurate chronology function. So a sample from a fresh crater where we know the location, that would be a perfect sample for me.
I'll introduce myself. Christian Brinkering, Grapplad Radio Lab. I have a question for Jordan. You mentioned there's a very different amplitude in the backscattering functions that you get from the lab versus the stuff that's measured in situ. What might the physical reason for that be? Is it a large-scale roughness thing, or is there completely another cause for that? What do you think?
It could be a couple things. The main thing that Shuai and I believe is that the kind of fairy castle structure, which is kind of how the regolith is composed on the surface, is probably not maintained when you bring the samples back to Earth, and that could explain the lower amplitude. It can also be affected by factors like the crystallinity of the samples, and we'd have to do more other analyses in order to verify that. But it's a good question. It's something that we've been thinking about.
Josh Cahill, APL. Jordan, with your analysis from the lab samples, have you given any thought to what they've seen on Mercury in terms of that being an easy case for determining kind of the relative percentage of volatiles relative to the more complicated case that we have on the moon?
I have not really thought about that much. As far as I understand, there is probably more ice on Mercury to make it visible, but beyond that, something that I need to think about more. But thank you.
Thank you, everybody, for attending.